various controls in production area can be classified as environmental control, the personal control, traffic control, housekeeping, and surface disinfectants. Okay, surface disinfection. Now, talking when we are going to see all these five, we are going to see environmental control in great detail, and we are also going to talk about these remaining four in brief. Okay, so let us consider the first control, that is the environmental control. Now, what do you mean by environmental control? Environmental control is nothing but control of air, control of temperature, humidity, and pressure. Why do we do this? Why do we do the environmental control? We do the environmental control in order to obtain a clean room, or in order to obtain an aseptic area or an aseptic room. Okay. Now, what is a clean room? Clean room is a room, okay, inside the facilities that have been provided inside the building. Clean room is one of the room, okay, which is constructed so as to minimize, so that there minimum number of particles, okay, they are either, these minimum numbers of particles are either introduced, minimum numbers of particles are generated, and minimum number of particles are retained. So if there is some particle that is entering inside, first of all, it should not enter. Okay, if any particle is getting entered, it should not be retained, it should be removed easily. Okay, no particle should be generated, first of all, okay, inside that room. The room should be such airtight, and such pressure gradient should be maintained, so that no particle enters inside this room. By chance, if any particle is entering inside this room, okay, or it is generated inside this room, then it should not be retained inside the room. Okay, it means what? In short, clean room is a room in which concentration of particles, we are talking about the dust particles, okay, concentration of these particles in air is controlled within the specific limit, specific low limits. Okay, so we want very less amount of particles in this room. So these kinds of rooms are known as clean rooms. What are aseptic area? In short, clean room is a room where less number of particles are present, so that these particles, we don't want it to be entered inside your product, right? Now, what is aseptic area? Now, aseptic area is a part of clean room. So you have a bigger clean room. Inside this clean room, you have an area which is an aseptic area. So you have an area as an aseptic area. Okay. And what is this aseptic area? It is a special area within the clean room where the microbial contamination is very low. Okay. So apart from, as it is a part of clean room, so the number of particles are going to be less. So in aseptic area, the number of particles are also less, as well as the microbes, the presence of microbes are also very less. Okay, so a clean room, aseptic area is a special area within the clean room, which is designed, constructed, okay, and serviced and used so that it prevents the microbial contamination inside the product during production. If you want to put it in other words, it is an area in which microbial contamination is controlled to the specific limit. In clean room, what is been controlled? Concentration of particles is been controlled, whereas in aseptic area, along with the particles, okay, microbial contamination is also controlled, because it is a part of the clean room, right? Got it? So these are the two definitions, important definitions, that is clean room and aseptic area. Now, how to classify the clean rooms? Okay, now clean rooms can be classified on the basis of the number of particles of a particular diameter that are present in the per cubic feet area. Okay, so it is based on maximum allowable number of particle, okay, size, diameter of particles. So maximum number of particles of a particular size in a particular volume, that is per cubic feet area. Now, depending upon this, they are classified into different class. That's class 1, 10, 100, 1000, 10,000, and 1 lakh. Okay. Let us, from our point of view, these three classes are very important. That is class 1, class 10, and class 100. Let us see one of the examples of class 1. Now, what do you mean by class 1? Now, class 1 is an area, okay, when you say that is, I have a class 1 area. So, it is a clean room whereby only one particle, okay. So, supposing this is the whole area, okay, this is the 1 cubic feet area, right? That is 1 feet of your, what you call that, length, 1 feet of your breadth, and the depth is also, if you take this depth, okay, inside, that is also 1 feet. So this is this much of area. In this area, only one particle is present, right? Okay, have you understood? So if you have an area of say 1000 cubic feet, your area consists of 1000 cubic feet, okay, then your class 1 is going to have only 1000 particles. In that whole area of clean room, you are going to have only 1000 particles, okay. This is known as the class 1 area, and the particle size is what? 0.5, okay, micron. This particle size, 0.5 micron particle size, only how much are present? 1 in 1 cubic feet, okay, in 1 cubic feet. Got it? Now you have another class, class 10. Have is, in 1 cubic feet area, you have 10 particles. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 10 particles are present, okay, in this 1 cubic feet area. So if you have an area, just for an example, if you have an area of 1000 cubic feet, okay, then how many particles are present? 10,000 particles are present. This is just taken for an example. If you don't remember this, then also it is okay. So 10 cubic feet, class 10 consists of 10 particles of size 0.5 microns, right? Below 0.5 microns, there may be particles that may be present, okay. ये नंबर अगर आपने याद नहीं रखा तो भी चलेगा, but below 0.5 microns, there may be particles that may be present, but above 0.5 micron, the particles that are present are 0. If you see 5 micron, 10 micron, say 15 micron, 20 micron, the number of particles present are 0, and number of particles, okay, of 0.5 micron are 10 or less than 10. In the similar manner, a class 100 clean room is defined as a room in which particle count in the air is not than 100 per cubic feet of 0.5 micron and larger in size. So 0.5 micron and larger in size, how many particles should be present? Okay, only 100 particles should be present. Okay, got it? So let us take this example once again. Class 10, 0.5 micron, number of particles that are present are 10. Okay, got it? Understood? Yeah, let us move. So it basically controls the number of particles that are present inside the room, right? Depending upon, so again, to come over here, class 1 is the most clean area, okay. Class 10 is the less clean area as compared to your class 1. Class 100 is lesser clean area. This class 1 and class 1 area is used for manufacturing of the, where the filling activity has been carried out. High risk activity is the filling activity, okay. This activity is carried out in the class 1 area, whereas your class 10 area, your other production activities, okay, compounding activities can be carried out in your class 10 area, and other activities, okay, which are accelerated to your production and filling can be carried out in your class 100 area, right? Got it? moving ahead, the clean room can further be classified as grade A, B, C, and D. Now, grade A is the area where high risk operations are performed. For example, filling, okay, then applying the stoppers, okay, then sealing the ampoules, vials, etc. All this filling and sealing activities carried out in your grade A. Grade B consists of aseptic preparation and filling. Okay, so preparation etc. is and filling is carried out in your grade B. It is nearer to your grade A area. So grade A के पहले जो भी activities will be carried out, that will be carried out in grade B area. Your filling activity can be carried out in grade A area also, or it can be carried out in grade B area also. Okay. Then you have grade C and grade D area. Now, these are the areas where less critical activities are being carried out. For example, manufacturing, etc. These activities can be carried out in your grade C and grade D area. But please remember, whatever it is grade A, B, C, and D, they are the part of your clean room. Okay, they are also clean room, but inside your clean room also you are classifying them as class 1, 2, class 1, 10, 100, thousands. You are classifying in that way. Inside your clean room, again you are classifying them as grade A, B, C, and D. But all of them are the clean room. They are the part of the clean room. Okay. Then there are two other terminologies which are also very important. That is the critical area and the general area. Okay. Critical area is the area where your contaminants can directly come in access with your product. Okay. So that is the most critical area you have to take care. Why do you call it as critical area? Because that is the area where the no person should enter inside that area. Okay. So as an example, in an hospital, ICU is what? It is a critical area. The operation theater, it is a critical area, right? And what can happen? The microorganisms, they can enter inside the body, isn't it? Because surgery etc. is carried out in a very critical area. They should be very clean. In the similar manner, in a production area, in a pharmaceutical area, production area where parenterals have been produced, okay, you again have a critical area where the contaminants or the particles can directly enter inside the product, okay, or the process. Whereas you have the general area, okay, it is the rest of the part of the clean room, okay, where the product cannot directly enter into the process, but through cross contamination it may enter inside the product. Hence these also area are required to be kept clean, but not as clean as your critical area. So you have a critical area and you have a general area. This is the another way of classification of your clean room. So your clean room can be classified as class 1, class 2, class 1, class 10, class 100, class 1000, or it can be classified as grade A, B, C, and D, or it can be classified as critical area and general area. Okay. All said and done, all the activities should be carried out in the clean area, right? Now, this was about the area. Let how you are going to control the temperature and air inside that area. We have talked about the particulate matter, how you are going to control it, and how you are going to now make this area a clean area. What are the equipments that you are going to use in order to make your area clean area, or what are the equipments that you are going to use in order to have environmental control, right? Environmental control is control of air, that is particles, control of your temperature, control of your humidity, and control of your pressure. Okay. Now the first thing that you are going to use in a clean room in order to maintain all this, okay, to maintain a proper environment is HVAC. What are HVAC? HVACs are the equipments that are used for heating or cooling of the air. It is also used for proper ventilation and for air conditioning. Okay, so HVAC here, S stands for heating, V stands for ventilation, AC stands for air conditioning. So you have the air which is heated or cooled, okay, containing less particles and which is properly conditioned, right? So what does the difference between HVAC and AC is what? AC usually gives you cold air, whereas HVAC can give you cold as well as hot air. So what does HVAC do? It provides thermal comfort and acceptable indoor air quality. Whatever is the acceptable quality, air quality, that should be present in a clean room, that has been provided by your HVAC. Moving ahead, now let us see how the HVAC works. Okay, you can see over here, you have outside air which is entering inside this unit, inside the HVAC unit. You have filters which are lined up over here. So this air, it is first filtered. After filtering of air, these are passed to the coils. These coils are either going to heat the air or it is going to cool the air. And this heated or cool air, so you have a chiller or you have a boiler, depending upon what is the temperature that has been required. The coils are either heated or they are being cooled, so that the cool air now enters inside, the heated or the cool air now enters inside the ventilated area or the clean room area, right? Whatever air is present over here, it is removed, okay, with the help of the exhaust, and it can be either thrown out. This room can be either, this air can be either thrown out, that is also possible, or this air is recirculated inside the HVAC. Okay, again it enters inside along with the outside air, it gets filtered. After filtering, it passes through the coil and it is again going inside the clean room, and this circulation goes on, whereby the quality, because of this unit, the quality of air is maintained inside the room. Okay, so what is done? Air is brought from outside. Okay, so it is brought from outside and it is pushed through the coils. So these are the coils, it is pushed through the coils. It can be either heated or it can be cooled, right? Okay, and it is again pushed back and it is being pushed, it is again pushed back into the workplace. Okay, at the same time, what is done? Whatever the air is been displayed from the room, right, it is sent back to the system. So this process is being continued. So this is how the HVAC works. One of the method of preparing cool air, what you call that, clean area. The second thing that you have to remember is about the laminar airflow. Now in your clean room, what is what is being supplied is the laminar airflow. Okay, you have the laminar airflow. Now what is the laminar airflow? It is defined as the air, okay, it is the air which is moving in the same speed and in the same direction. So this is the direction in which it is moving, or this is the direction it is in which it is moving. So the air is going to move in the same direction, okay, at the same speed, and there is not going to be any crisscross of the air stream. For example, the air that you are now at present sitting, or I am sitting, it is in the crisscross manner. Some air is coming from here, some is coming from here, some is coming from here, they are coming from all different directions, and they are moving in all different directions. Okay, so they are coming and moving in all different directions. This type of air is known as turbulent flow. So the air is what? Turbulent. Whereas when the air moves in one direction, so this is unidirectional with the same speed. So the direction as well as the speed, okay, is same. In this case, these types of flow are known as laminar airflow. What is the importance of laminar airflow? Okay, now laminar airflow, as the air is not in turbulent fashion, so whatever particles are present, supposing these are the particles that are present inside the room, okay, these particles, because of the flow of air in unidirection, okay, they are swept through, okay, they are removed. So they are removed from this, okay, area, and the number of particles that are present inside are less. So this is a vital device in order to control the particle contamination. Laminar airflow, they control the particle contamination. Now what are the types of it? But okay, before we go to the types of it, now what does it actually do is, as I told you, it sweeps the particle. So this is the particle, it is sweeping the particle in the uniform direction, in this direction. And from here, as it moves down, from here it is getting removed from the system, from the room. Okay, so it sweeps the particle in uniform direction from the cleanest area. So this is the area which we want clean. So it removes the particle from the cleanest area, okay, under the hood. So this is supposing we want this area to be clean, right? So whatever particles are present over here, they are getting removed. Supposing you have, now there are two types, as I told you. You have horizontal and you have vertical. Okay, so if the air is coming from the top, it is going to remove in this, it is going to come top, from top, the particle is present over here. So this particle is going to move along with the air, and then it is going to get removed from the system, okay, from this hood, right, wherever the critical activities that you are carrying out, okay, and it is going to exit that area, whatever the area that you want clean, free from particles, that area, from that area is going to get exited. So this laminar airflow helps to remove the particle from a particular area, okay, in order to make that area clean. Okay, now you have laminar airflow cabinets. These are also known as transfer hood. As yesterday, I think so, Ritika was asking, as clean benches. And what they do is, what they are known as clean benches because the air in this area is thoroughly cleaned by precision filtrations. Okay, and what are the filters that have been used? The filters that are used are known as HEPA filters. Okay, so what happens is, again, you have two types. You have vertical airflow and you have horizontal airflow. Now what happens in vertical airflow? From the top, they are going to come, right? They come through this HEPA filters. These are the HEPA filters that are present over here. We are going to talk about HEPA filters in my next slide. So the air from outside, they come inside the HEPA filters, and from here they move down, and here you can see there is unidirectional flow of air. So it is upside down, or it may be horizontal also. The person who is doing his working over here in this area, he's been working, right? So if you are sitting over here, then the air comes from the top and it gets removed from below. If you are working, if you have an horizontal airflow, then in horizontal airflow, the air comes from the front and it moves outside. Okay, so this is how is the flow of air in case of horizontal. It is forward from the filter, okay, positioned behind your workstation or work surface. Okay, so it is positioned. So this is your work surface and it is positioned behind your work surface. Whereas in case of vertical, it is positioned, this is your work surface and it is positioned above your work surface. So positioning is above in case of vertical airflow, and position is behind the work surface in case of horizontal airflow. So you have vertical as well as horizontal airflow, right? These are the two types of laminar airflow. Now let's see the side view of laminar airflow. How does it work? You have the air coming from outside. You have the primary filters which are assigned over here. From here they move inside the HEPA filters. Inside the HEPA filters, so these are the HEPA filters. These HEPA filters clean the air, and now the air is entering inside the sterile area in the form of laminar air. Okay. So we talked about HEPA filters. So what are HEPA filters? HEPA filters are called as either high efficiency particulate absorber, as they were called originally. Now they are called as high efficiency particulate air. So instead of absorbers, now they are called as particulate air, that is high efficiency particulate air, or they are also called as high efficiency particulate arresting. Okay, or this A can be also sometimes called as arrestance. Okay, but generally HEPA stands for high efficiency particulate air. So it provides the air which is of high efficiency with minimum number of particles, right? So the HEPAs are nothing but they are the type of air filters. So this HEPA, where they are placed inside the hoods from where the air enters inside the HEPA filter, and they are blown in the form of smooth laminar flow towards the user, either from top or from the sides. They come. Okay. And what do? They clean the air. And what is the efficiency of it? We say it is high efficiency. What is the efficiency? It traps near about 99.97% of particles that are of 0.3 microns. Okay, so 0.3 microns and more particle size, near about 99% of the particles have been. And where are they trapped? They are trapped inside these glass fibers. So these are the glass fibers. Okay, they are interlaced glass fibers which are present inside these filters. Okay, so inside these interlaced glass fibers, all your particles that are there, okay, which are coming from outside, they get trapped into it, and from here it is going to come out. So all these particles, they get trapped into it. Okay, and these glass fibers, they are countless. They are twisted, they are turned in all the direction in order to form a fibrous maze. And inside this fibrous maze, what is happening is your particles are getting, okay, or jammed, right? They are getting entangled, okay, inside this maze, and thereby the air that is coming out is free and devoid of any particles. Control is the control of the personnel. So the person who are working inside this sterile area need to be controlled properly. What do you mean by controlling of the personnel? First of all, the persons who are working, the operators, the supervisors who are working should be neat, they should be orderly, they should be reliable, and they should be alert. These people should be possessing very good health, and you should be you should carry out regular physical examination of this person. Okay, either weekly or you can say within 15 days, you should carry out the physical examination of these people who are working in your parental area. Then they should not have any headache, cold, sore throat, or any kind of infection. Okay, should not be there. And for this, they should be regularly examined, physically examined every 15 days. They should wear everything. Okay, the attire should be very proper. We are going to talk about the attire also. Okay, in your next slide also. Then they should be wearing a proper attire. For example, they should be having the hoods, they should be having face masks, they should be having shoe cover, they should be having sterile rubber gloves, etc. that they should be wearing. That's why we are providing the facility, isn't it? The change room facility. Inside the change room, they should change themselves, and then only they should enter inside the sterile area. They should take a full body wash, and they should also take a soap shower before entering the manufacturing area. They should, before entering inside the manufacturing area, they should also take the air shower. So air curtains, air showers should be present. So whatever particles that are accumulated on your dresses, etc., on your body, that all should be removed, okay, from the body, okay, from the clothes, right? So you should take a proper air shower, and then only you should insert inside the production area. The uniform that you are wearing, okay, it should be made up of synthetic fibers. That's why, example, Dacron. So that the particles, if it is made up of cotton, etc., then there are chances that the particles may get stuck to this, and then it may be transferred from your